this is LeetCode problem number 75, and the problem is nothing but sort color. Okay, and we're given an array of n objects that are basically nothing but colors, and these colors are red, white, and blue, and we need to sort them in place so that objects of the same colors are adjacent. Okay, and with the colors in the order, first of all we will have to do red, then white, then blue. Okay, so, and we also said that the integers 0, 1, and 2 are represent to the color like red, white, and blue. So 0 is for red, 1 is for white, and 2 is for blue. Okay, and you must solve this problem without using any library sort method. Okay, so we are also not allowed to use any inbuilt sort method. Okay, and we'll able to understand this problem with this example actually. So you can say this is the array that only contains 0, 1s, and 2s. Okay, so 0 for red, 1s for white, and 2 for blue. So what I need to do, we need to place all the red colors or all the zeros to the beginning. So you can say all the zeros are beginning, and we need to place all the 2s, or you can say all the blue colors, at the last of the array. Okay, at the ending position you can say, and all the white colors, I mean all the ones, will be at the middle of 0 and 2. Okay, that is the thing we need to do. So basically we need to sort the array like this. Okay, and we need to sort this in place, I mean with constant space. Okay, now let's analyze this two example to find the optimal solution for this. Okay, so you can see this is the example. Okay, so this example, this array only contains zeros, ones, and twos. Okay, what I need to do, we need to place all the zeros at the beginning position, all the twos at the last position, and all the ones at the middle position. Okay, so now as we already know that we just need to sort this array. Okay, so we already can do, we can simply apply some sorting algorithms to sort this. Okay, we just need to apply some in place sorting algorithm to sort this. Okay, so we have some in place sorting algorithm like heap sort. We can probably use that, but if we use any kind of algorithm, sorting algorithm, so this will take nothing but n log n time complexity. Okay, so you can see this will take n log n time complexity. So yeah, we can do more better than this time complexity. Basically we can come up with, we can achieve linear time complexity for this example, and further we'll be discussing this approach actually, so that we can achieve linear time complexity. Okay, so right now we can also see that this array only contains zeros, ones, and twos. Okay, so probably you can think that, okay, we'll be taking 3 pointer, one for counting the frequency of 2, one for counting the frequency of 0, and another for counting the frequency of 1. Okay, then we'll simply sort this array. Okay, so this is a kind of approach. Okay, we can do this, but if you carefully notice the question, in the question we are already given that we just need to consider the elements of the array as object. Okay, object of colors. So if this kind of object, then we can't use this kind of counter variable to count the frequency for object. Okay, so this approach is not appropriate, okay, for this problem. Now let's talk about the final approach that we just need to apply to solve this problem, and that will be nothing but two-pointer approach that we are continuously doing throughout the last videos. Okay, so we'll be using the two-pointer approach. Okay, and as usual we'll be taking 2 pointer to solve this problem, and our first pointer will start or point to the very first position. Let's say the name is start. Okay, and our next pointer will point to the last position, and let's say the name is nothing but end. Okay, and we'll also choose a loop to iterate through the array, whether it can be while loop or for loop. Okay, we'll be using any one of this loop, okay, to iterate through the array, and we'll iterate through the array just to check whether our current element is 0 or 1 or 2. Okay, because we have only these three kinds of elements in the array, right? So if we encounter 0, then basically with the help of this start pointer, will place all the zeros at the starting position, or we can say at the beginning of the array. Okay, if we encounter 2, okay, then we'll place this 2 at the end of the array using this end pointer. So basically will be placed all the 2's to the end of the array using this end pointer, all the zeros to the beginning of the array using the starting or start pointer, and usually all the ones will be in the middle of the twos and ones, twos and zeros, right? That will be the thing we just need to do with this 2 point wrapper. Okay, so now let's erase everything and let me discuss the process what I need to follow. Okay, so as we said that we just need to have a pointer that will be nothing but start pointer. It will start from the very first index, and we'll be having another pointer that will be end pointer, and it will point to the last index of the array. Okay, and we'll use a loop to iterate to the array. Let's our loop will be while loop. Okay, and we'll use a variable, okay, to iterate through the array. So now let's, this variable will be I, and it will start from 0th position. Okay, it will start from 0th position, you can say. Okay, so you can say this is the loop iterator, okay, just to iterate through the array. Okay, now what will be our condition? Our condition will be very simple. Okay, so condition will be until I is less than end pointer. Okay, so you can say why this is the condition. Okay, so as you already said that after the end pointer every element will be already sorted, or every element will be nothing but twos. Okay, so we don't need to go beyond this end pointer. That's why the condition will be until I less than this. Okay, now we just need to, every time we just need to check whether the current element, okay, whether what is the current element. Okay, so we just need to check what is the current element. So you can see this only contains zeros and ones and twos, right? So current element can be either 0 or 1 or 2. Okay, so we'll be checking that if the current element is 0. Okay, if the current element is 0, then we already said that we just need to place this 0 at the very beginning position. Okay, so what I need to do, we just need to swap this. So if the current element is 0, we just need to swap, you can say we just need to swap the value of the iterator pointer and the value of the start pointer. Okay, we just need to swap this, and we also need to increase the I pointer by 1 place and start position by 1 place, right? Because this start position is already filled with appropriate element, filled with 0, that's why. Okay, so that is the thing we need to do if we encounter current value as 0. Okay, now again we need to check whether the current value is 2. Okay, so whether the current, if the current value is 2, then what we need to do, we need to simply swap the value also. Okay, we just need to swap the value of current element with the end pointer, right, with the end pointer. And we, in this case, we also need to decrease the end pointer by 1 place. Okay, so this is the thing, but in this position we are not going to increase the I pointer. Now you can ask me why we are not increasing the I pointer. So you can say the I pointer, the loop iterator, start from the starting position, so it already check all the elements of the starting position, right? That's why we are increasing the I pointer at the time of 0, but at the time of 2, okay, we can say we are not already, we not check the value of the end pointer. That's why we are not increasing the, we are not increasing the I pointer in this time, because this value can be 0, can be 1, can be 2. Okay, so we just need to place these elements also at the right place. That's why we are not increasing. And else will have only one condition, that is nothing but the current element will be 1. Okay, so in that case we will simply increase the I pointer by 1 place, because in that case we already know that we just need to place 1 at the middle of zeros and twos, right? So this will be the whole process we just need to do. Okay, and you can say this is very simple. Now let me jump to the code section so that we can code this approach. So first of all, we just need to take 2 pointers. So our first pointer name is nothing but start. It will start from 0, and the second pointer will be nothing but end, and it will point to the last position of the array. So this is nums dot length -1. Okay, that is the thing. And as we said that we just need to iterate through the array using while loop. So for loop iterator, I'm taking an variable that will be nothing but I. It will start from also 0. Okay, so now let me write the condition. So condition will be I is less than equals end, right? This will be the condition. So what I need to do, every time we just need to check what is the current value, right? So if the current value, that means nums of I, is nothing but 0, then what we need to do, we need to swap this current value with the start position, right? So for swapping, I'm directly doing the swap operation using, temporary value. Okay, so let's use a temporary value and store the starting pointer value. Okay, so this is nothing but nums of start. Okay, and we just need to place the 0 value to the starting position. Okay, starting pointer value, right? So now nums of start position value will be nothing but 0, and we just need to place nums of I as a temp. Okay, so this is the swapping operation. Now what I need to do, we said that we need to increase the I pointer, I mean loop iterator, and we also need to increase the start pointer, because the start pointer is already filled with the appropriate value, that is nothing but 0. That's why. Okay, my mat. Okay, now what will be the next condition? If this is not kind value is not 0, then what can be happen? Kind value else if it can be, I mean the nums of I or current value can be equals to 2, right? Now if the current value is 2, so what do we need to do? We need to again swap the value of the current value and the end pointer value, so we'll be doing the same thing. So that's why let me copy this. Okay, so pasting the here. Okay, so but this will be nothing but start, this will be end. Okay, and this will also end. Okay, end, but the value is nothing but right now the value is 2, and this will be temp. Okay, and in this case we just need to simply decrease the end pointer by 1, because right now the current end pointer is already filled with 2, right? That's why we need to decrease the end pointer. But right now we are not increasing the loop iterator, or you can say I, because for this case I already loop iterator, I already iterating from the start position. That's how you can say it already checked the value of the start pointer. But for the end pointer, it haven't checked the value of the end pointer. So the value of the end pointer can be 0, 2, or 1. So we also need to place the value of end pointer at its right place. That's why we are not increasing the I pointer. Okay, and another, it can be only one case. In this case our current value can be 1 only, right? Because we already explored the case 0 and 2. Okay, 0 and 2. So for 1, what I need to do, we need to simply increase the I pointer, because we need to place the value of 1 in the middle of zeros and 2s, right? So we are already placed the 2s at its right position and 1s at its right position, right? So already place 1s at the beginning and 2 at the end, and so it will simply put the 1 value. Okay, all the ones at the middle. Okay, we don't need to do anything, we just need to simply increase the pointer value if we encounter with 1, right? That is the thing. Okay, so this is the whole code. You can see this is very simple. Okay, so now let me run this code to check whether we have some error or not, and you can see it's working very well. Now let me submit this code. So yeah, it's get submitted. And if you like the explanation and understood it, then please do like and hit the subscribe button.